Okay, so for example, how can a student get, let's see, 3 questions correct out of 5? 3 questions correct out of 5. 3 questions correct out of 5. It turns out there are 10 ways. 5C3 or 5 choose 3 is equal to 10. For example, the student could get question 1 correct, question 2 correct, and question 3 correct. The student could get question 1 correct, question 2 correct, and question 4 correct. The student could get the last 3 questions correct, number 3, number 4, and number 5. It turns out there are 5 choose 3 or 10 ways of doing this. All right, so n choose x is the number of ways that a student can get x questions right out of n questions. P is the success probability per question. X is the number of successes. Q is the failure probability per question. N minus x is the number of failures. So for example, if there are 5 questions, if n equals 5 questions, x equals 3 correct, then n minus x equals 2 wrong or incorrect. Okay, so you can make these computations. Probability of 0 correct. That's the probability of getting all 5 wrong. It makes sense that it's 5/6 to the 5th. The probability of getting each question wrong is 5/6. Multiply 5 copies of this by independence, and you get about 40%, 0.402. Remember, on your calculator, make sure you process 5 divided by 6 first before raising to the 5th power. P of 1, 5 ways to get 1 question correct out of 5, and only 1 question correct, right? Again, about 40%. That's a coincidence. The probability of 2 questions correct, that's about 16%. The probability of 3 questions correct, let's go through this in detail. 5 choose 3, 5C3. We just mentioned that that binomial coefficient was 10. There are 10 ways of getting 3 questions correct and 2 questions wrong on a test of 5 questions. That's 10. All right. The probability of getting each question correct is 1/6 because it was A through F for each question. 6 possible options. The student is guessing randomly. 3 questions correct, 1/6 to the 3rd. The probability of failure, the probability of getting a question wrong, Q is 5/6, which is 1 minus a 6th. 5/6 to the number of failures or questions wrong, that's 2. Right? You put these all together, 0.032, or about a 3% chance that the student gets exactly 3 questions correct out of 5 based on random guessing. P of 4 is smaller. P of 5 is very, very tiny because you have, for example, 1/6 to the 5th over here, which is teeny tiny. 5/6 to the 0 is 1. 5 choose 5 is 1. So it's basically 1/6 to the 5th. The probability of getting 5 questions correct, success probability of 1/6 for each question, 1/6 times 1/6 times 1/6 times 1/6 times 1/6, it's almost 0. It's this. So that's how you calculate the probabilities. Okay. So when all is said and done, you end up with this binomial formula. Applying it, you get this. For this distribution, here is the probability table. The binomial probability distribution for this distribution as a table. Now, why does this make sense? Why does this make sense? Okay, so let's take a look at one way to get 3 questions correct out of 5. Well, one way to get 3 questions correct out of 5 is you get the first correct, the second correct, and the third correct. Whereas number 4 and number 5 are wrong. So what's the probability of getting number 1 correct by random guessing? 1 out of 6, which is the value of P. The probability of getting number 2 correct, 1/6. The probability of getting number 3 correct, 1/6. Now, the probability of getting number 4 wrong is 5/6, which is Q, and the probability of getting number 5 wrong is 5/6, which is Q. So that's one way to get 3 questions correct out of 5, if you get the first 3 correct and the last 2 wrong. The thing is, though, there are more ways of getting 3 questions correct out of 5 questions. In fact, there are 10 ways, 5 choose 3 or 10 ways, which means that this probability, this is the probability of getting question 1 correct, question 2 correct, question 3 correct, and question 4 wrong, and question 5 wrong. This is only one way of getting 3 questions correct out of 5. And this is the probability of that one particular way. But there are 10 ways to get 3 questions correct out of 5. So this has to be multiplied by the 10. Hence, P of 3 looks like this. 10 ways to get 3 questions correct out of 5. 1/6 to the third, 5/6 to the second. Because we may as well look at this easy case where the 3 questions you get correct are the first 3. But it's the same probability for all 10 ways of getting 3 questions correct out of 5. Again, that's how you get the table. You don't have to know that for homework or exams, and that, my friends, is the binomial distribution.